Hello students, Namaste. In the last class, we were discussing about the rules for block diagram reduction. Correct? So around 11 rules we discussed. So now all these rules can be applied to reduce the given complex block diagram. Now let us take up a problem. So it is given that obtain C of S by R of S using block diagram reduction rules. That means we have to use only those 11 rules to reduce the block diagram, and we know C of S by R of S is the Laplace transform of output to the Laplace transform of the input, which is just nothing but transfer function of the given block diagram. So now here they have given this block diagram. Correct? Now in this block diagram you have 1, 2, 3. Three summing points with the forward transfer functions G1, G2 and G3 with feedback path transfer function H1, H2 and H3. So this is the given block diagram. Now I have to reduce this block diagram using the block diagram reduction rules. Correct? Now considering this block diagram, we have to separate the feedbacks to the respective summing points. Which means just find out what is the feedback H1, H2 and H3. Correct. Now we have to separate out those feedbacks to the respective summing point. How many summing points are there? 3 summing points. 1, 2 and 3. There are 3 summing points. Let us see where those feedbacks are going to. Now the output of H1 is going to the summing point 2. Correct? Correct, no? Fine. Also the output of H1 is going to H2. Done? Now in this block diagram, okay, we have taken in this way. Now as I said, the output of H1 is going to summing point 2. So see here, I have taken H1, this point. Okay, I have taken H1, it is going to summing point 2. Over, look at the sign, negative. Fine. Again, H1, H2 is there. The output of H2 is going to summing point 3. Correct? Now we can see here, this one. H1 and H2, because the output of H1 is going to H2 and the output of H2 is going to summing point 3, that is this summing point. Okay, fine. Over. Then the output of H1 is given to H2. Again the output of H2 is also given to H3. So H1, H2 and H3 should go to summing point 1. The same thing has been taken here. H1, H2 and H3 is going to summing point 1. Fine. Okay. Now the block diagram is very simple to analyze here after making the certain arrangement. That is, we have separated out the feedbacks to the respective summing points. Correct? Now you can observe here H1 and H2 are in series. So it becomes H1, H2. Correct? Fine. Now you can see here, if I take this region, if I take only this region, okay, it is marked here. Okay, so you have one summing point, one forward block, one feedback block, okay, and then one takeoff point. So that can be called as canonical form of closed loop system, or simple form, or simply we call it as minor feedback loop. MFBL stands for minor feedback loop. So here I have taken it as MFBL1. That means this is the first minor feedback loop which I am going to reduce. So now here if you come for MFBL1, the loop which we have taken, okay, generally when you have canonical form or simple form of closed system, you can write them in terms of g of s divided by 1 plus or minus g of s into h of s. Correct? Where positive sign is taken if the feedback is negative, and this negative sign is taken if the feedback is positive. Correct? Okay. Now let us see here how for MFBL1 we can write in this form. Okay. Now, so these are the form g of s, these are the form h of s. So g of s divided by 1 plus or minus g of s into h of s. In place of g of s we have g3, in place of h of s we have h1, h2. Correct? So the feedback is negative, so it should be 1 plus g of s into h of s. Correct? So now, look here. In place of g of s you have g3, so g3 divided by 1 plus g of s into h1, h2 is what? h of s. So we took the minor feedback loop 1, okay, and now that I'll be taking it as x, okay, that I'll be taking it as x. It's taken here. Correct? Now finally, after reducing the minor feedback loop, the block diagram reduces too. So I written G1 as it is. Okay, second summing point is also written. So now along with the third summing point, okay, we have this one. Correct? So G3 divided by 1 plus G3 H1 H2, that is some minor feedback loop 1, and G2 was as it is after the summing point 2. Correct? Now these two are in series. Correct? Here I have taken X so that it will be easy for me to write the blocks, and finally later I'll substitute the value of X. So X is taken to be G3 divided by 1 plus G3 H1 H2. Correct? No? Now if I take these two are in series, then that will be G2 into X. Correct? Okay, same thing written here. G2 into X. Okay, whole divided by 1 plus G2 into X into H1. Now you might be wondered how it is. So already these two are G2 into X. So this will become one block. Correct. Now one forward block, one feedback block, one summing point, and one takeoff point if I consider this region. Okay, now that is taken to be MFBL2, minor feedback loop 2. So first one is already simplified with this, and that is taken as X. Correct? And now I got second minor feedback loop 2. Okay, now I am going to write it here. So G2X divided by 1 plus G2X H1. It means this will be G of S, this will be H of S. So G of S divided by 1 plus G2X will be G of S, H1 will be H of S. The feedback is negative, so here we have the positive sign or the plus sign. Over. Now this minor feedback loop after the simplification is taken as Y. Okay, now I'll take what is here, G2 into X, correct, divided by 1 plus G2 into X H1. I've taken G2X divided by 1 plus G2X H1, correct. Now I'll substitute for X. X is known to be G3, 1 plus G3 H1 H2. Fine. So now here I have G2. I substitute for X. G3 divided by 1 plus G3 H1 H2 whole divided by 1 plus G2 G3 divided by 1 plus G3 H1 H2. That means I use it for X. Fine. And then multiplied by H1. Over. Next. Fine. In the denominator, you just cross multiply. So what is going to happen? The numerator remains same. It will be G2 G3 divided by 1 plus G3 H1 H2. This one. Okay, next. When you cross multiply here, this 1 plus G3 H1 H2 gets multiplied to 1. So 1 plus G3 H1 H2 plus, okay, plus G2 G3 H1 G2 G3 H1 whole divided by 1 plus G3 H1 H2 whole divided by 1 plus G3 H1 H2. So this and this gets cancelled. So what are you left with? G2 G3 divided by 1 plus G3 H1 H2 plus G2 G3 G1. Sorry, G2 G3 H1. Over. Okay, next. I got this entire simplification. that is the simplification of y, correct, after substituting for x. Now, therefore, g2x by 1 plus g2x h1 is given as g2 g3 divided by 1 plus g3 h1 h2 plus g2 g3 h1 was taken as y. Now, the above block, that means this block, okay, this block reduces to okay, g1 into y, because g1 and y are in series, the blocks are in series, so multiply the blocks, g1 into y, okay, g1 into y, and you have one feedback block h1, h2, h3. So you have h1, h2 and h3 over now. So this will be the last minor feedback loop. So I am not taking it as MFBL3, I will just take it as the final one. No, so it is MFBL. So beyond this, it's completely simplified. That means the block diagram is reduced. Now this will be G of S, this will be H of S. So therefore, C of S by R of S, that is the transfer function or the closed loop transfer function, is given by G1 into Y, G of S whole divided by, look at the feedback is negative, so it is 1 plus, okay, G of S, G1 into Y is G of S, so H1, H2, H3 is H of S, correct. Now use the value of Y, so now C of S by R of S, so I use the value of Y, so G2, G3 divided by this one, okay, again 1 plus G1 is there as it is, okay, I use the value of Y, so this value I am using it, so H1, H2, H3 is done as it is. After the simplification, okay, we are going to get the final expression or the transfer function C of S by R of S equals G1, G2, G3 whole divided by the respective denominator. So from the complex nature of the block diagram, we have separated out the feedbacks to the respective summing points, okay, and then we have used the rules. So this is rule number 2, blocks are in series, multiply the blocks, correct. And now this canonical form or the minor feedback loop is just nothing but the rule number 8. We have used rule number 2 as well as rule number 8. Here also you can see H3, H2 and H1 are in series. Again, this will be rule number 2. So usually in this block diagram reduction, we have preferred rule number 2 as well as rule number 8. So wherever possible, minor feedback loop is reduced, okay, and we try to finally make it one summing point, okay, like how it is done here, one summing point, one feedback block, one forward block and one takeoff point, correct. So this is the last block representation of this complex block or this complex block, okay. And finally, after the simplification, okay, or taking the minor feedback loop, we got the final expression using this, and later we substituted the value of Y, okay, and finally we got the ratio of C of S by R of S, that is just nothing but transfer function of the given block diagram using block diagram reduction rules. Thank you.